This is the first time that I'm attempting to do a unwrap, unveil, mainly because most of my things I know what they are, but this particular one is a bit of a mystery package. I've had photographs, but I've absolutely no idea how it's going to turn out, whether it's going to be a good purchase or a bad purchase. I'll explain as we get on what the mystery package has got in it. So let's cut this open. This has come from the United States. Unfortunately in the UK we end up paying VAT, import duty and all sorts of other charges of one sort or another, which make bringing these things into the UK very expensive. But sometimes it's the only way of getting hold of what you really want. Right, let's open that. Just anxious to know how much of it might have got damaged in transport. But I may be lucky. I may be lucky. Well, there's the first casualty. Those are going to be a bit of a pain to get sorted. Two of the gib screws have broken off. That's a real nuisance. They should have really been taken off before they were put in. Right, but the rest of it doesn't, on the face of it, not too bad. Oh, there's the other one that's broken. Well mangled. So let's take all this packing out of here. Right. There's four screws that go in the top. Well, on the face of it doesn't look too bad. That's alright. This one has I think I can probably bend that straight again. It's been bent there and bent there. If it breaks off I'll just remake it. Right, that locking lever seems to be alright. Quite a lot of free play in this, and I think that's just the way that's tightened up. Yeah, that's just moving there. Right, now I can tell you what this is. This is a traverse milling attachment for a Rivett lathe, and this sole here sits on top of my existing saddle arrangement on the Rivett lathe, and it enables, you take the old one off, you put this on, and it enables you to do, by turning this you can turn it through 180 degrees. You can mount it on the far side this way round, or you can turn it round and mount it the other way. It's graduated along the base here, and on here someone's added a scale and on here, this chunk here shouldn't be here. So I'll take that off now and just investigate why it's there. But so far, and that's the draw tube, and these two levers here are the locking levers to lock this in place so it doesn't go up and down. Right, it's missing a plate that goes on the top and a spindle up middle to turn it up. While I was waiting for this to arrive, I've turned these bits up, which is a handle to sit on the top, and underneath it this enables the top to be locked. I can show you that later. Now, I had fears that the crossfeed screw would be bent, but it doesn't look as if it is, which is a bit of a relief. And that's, I think, the way you adjust the amount of backlash. Oh, well, the backlash isn't too bad. That's good. So far, things look pretty good. So let's just see if I can get this mechanism, whatever it is, off the top there. Now, I did worry that this mechanism has been added because the casting's cracked underneath, but we'll see in a minute whether it is. That screw. Good, that's got that out of the way. Now I've got to take that stud out. Oh, good. It's got a hole through it. That stud's now out, and clearly it's going to need to have various holes filled and made good, just as it really looks more like it should do. Let's just see if I can get this off. Got one of them out. managed to find where the screw is. The nut is for the lead screw, which is behind here. Oh, and there's a screw there, which if I undo that, I should be able to get this rest of this apart. Yes, bear in mind there are no instructions anywhere on this, or decent drawings. Ah, good, all that seems to be in order. Really, really good. This is turning out to be much better than I rather feared it might do. And that's the locking lever. Take that out, that's not needed now. And all that remains is to remove this band, which I have absolutely no idea what that was supposed to do. But it clearly doesn't belong to the Rivett company. Quite sure how to tackle this. Something thin that'll get down there. Tap this down, it will gradually spring apart. Yeah. Well, that broke a bit, so that's cast iron around here, and I don't think I can worry too much about it. None of the other photographs I've got show anything in this position here, so I'm just going to assume it's nothing to do with Rivett. It's just going to come off in sections. Right, well, that's that part of it fully disassembled, and I've just got these plugs to take out, and I'll probably just put them back in to fill them. Now, I've still got this to get apart. Right. These off now. I know that that doesn't belong on here because it says made in Germany, so for sure that was never on it, on any Rivett. bit weird that that nut doesn't want to come out. I think I know what the problem is. It's going to need this assembly out first, but that is held in. Just by that screw, I think. If I can take the screw out, then it'll, I think, come loose. Okay, this is going to take me a little while to decide the best way of dealing with this. I've got that, and I've got this screw here, both of which are stopping it moving. I just moved these pieces out separately so you can see the frosting that's, or scraping marks rather, which are on the surfaces. I just love this. I think the care and the detail that goes into something that's not going to be seen is just absolutely mind-blowing. And that's the inside of this block here. Trying to see the inside of this so you can see. Very difficult to see that. And you can see there's almost no wear on this. Just a little bit at this end and that's all. Looks fantastic. The skill that these early guys had is just amazing. I should probably, I don't know, maybe 1930s I would think this is. You can probably just see at the bottom there a number 19 stamped. And the 19 is a series of stamping marks that go on all the parts so that they get assembled, because they're all handmade. So yeah, even that nut's got a 19 stamped on it. There's a 19 somewhere in here, but I can't see it at the moment. Okay, there must be a 19 on here somewhere. Yes, amazing for the date of construction, and you think that Rivett did not produce very many of these components at all, for basically what's here plus the missing top and the screw thread, that they were charging $390 in 1944 in the catalogue, which is a huge amount of money. The lathe itself was something like $1,100, so this was very, very expensive piece of equipment, almost the price of a small car, and that's why very, very few were sold, and certainly very few made their way to the UK, because they weren't part of the standard Lend-Lease units that came across to the UK. They had to be ordered separately if anybody wanted them. But I've been jolly pleased to get mine, so yeah. Anyway, I thought you'd just be interested to see the lovely standard of making of this. It's absolutely glorious, and all hidden. I mean, you just don't see any of it. I love it. It's fantastic. Engineering at its very best. I've now managed to get to the bottom of what the problem was with having made up this weird contraption of a hoop thing round the edge there. I've taken it off and I've filled all the holes, you can see here, and rubbed them down. It works well now. I had to make one modification. This is the clamp, and I've got one screw to rub down still, and these are the clamps that stop this sliding up and down. So you lock it on those levers there, and the way that works is quite ingenious. There's a little peg there and another one there, and when you push these levers, they just move very slightly in that direction. Hardly even notice it. It's a very small amount of movement, but it's enough. Again, that's the scraper marks from when it was first made. This has never been moved up and down very much, and you may just see here there's a circle, a disc, and that's where the arbor ends that goes up to the top with the handle. And these four holes here are secure a disc that goes on the top there, and that disc goes upwards and recesses itself inside the top hat that sits on top of here. And then I'm not quite sure what all these holes here are doing, whether they're original or not. There doesn't seem to be any particular reason for them. They're threaded, so I'm just going to leave them alone. And the other thing that's even more weird is on the back side there's a whole lot more, and it must be that this is fitted this way round, because that's then flat across there, so that can then drop down in there, and that's marked oil for the oil. Perhaps, oh, and one thing I hadn't mentioned is that the spindle here has an oiler at the front, so we just undo that screw, take it out, and then this can be oiled. Take this off, and this is hard steel, and it's just a little mark, but not very much, so I'll give that a polish before I put it back in. And inside there, that's cast iron, so it's hard steel into cast iron, so that would be quite a suitable high-speed spindle. As I mentioned before, I don't think that pulley has anything to do with rivets. I think that was added later. There should be a pair of gears, one on the back of here, and then one where this gear mates. So I've got a bracket to make up that goes on the top here. So we end up with the shaft power being transferred at 90 degrees, so that's the way it turns there, and its power is transferred via a shaft here and a pair of gears. Most of the original ones are worm gears on the top part that goes across, and a toothed bevel gear, well, angled helical gear with a slightly circular form to take the gear wheel, the worm wheel that goes in there. On mine, I've decided I'm going to use crossed helical gearing so that I can run this at 50% of the RPM of the motor. So I can run it faster, as fast as that, which would be about 1400 RPM, or lower than that if I chose to. Now, the reason that this was a problem, see, it'll come up very nicely. Be pleased with the way that's come up. On the bottom here, it turns out that this screw is absolutely vital it's done up tight. If it isn't, then this can move about. Yeah. When I look at this, there's a bit of wear here, and I think I've decided that I shall leave that alone. I could scrape it all flat, but then that would make a bit of a mess there. I've got a mass of parts here, all assembled, and some of them ready to go back together. And the first part we'll have a quick look at is the slide. You can see I've fitted, if you look carefully you can see inside that there's a sleeve, quite long screws. What I might do is to just recess those a touch. I'll cut these screws down so that they're the same sort of length as the original, and I may just turn the heads down a touch as well. They're not perfectly centered on the previous holes, but not too bad. So yes, these heads could be turned down. They're actually the nearest I could find that was the right sort of size was 4BA, which I happen to have. Some nice strong steel screws. So when I put all this together, the slide was very stiff, and I noticed that it had been beaten on quite heavily in places. If you look here, somebody's been banging away at it and there to get it apart. When it was put together, the screws for the slide, gib screws, really didn't need adjusting at all other than to lock it. So someone had been banging away to try and loosen it up. I've eased it slightly so that I've taken all the burrs off where they affect the way it moves. So as I say, it is, you can see now, moves freely, but it's a stiff movement, which is probably good actually. Now the most interesting one is the spindle. I've been working really quite hard on this. The spindle is tapered on this section here. It's not parallel, and this shoulder here is at 90 degrees, 45 degrees on each side. This part here, which is now shiny, is where I've resurfaced it, and the net effect of that was to allow this to sit a little bit further in than it was before. And the problem with that is, clearly if this distance there is up here, then that will sit further in, and the taper will bind on the taper inside here. So the first job I did was I put this in the chuck and turned the taper in, and ground it, took it back out, and when I tried this in, I first of all hadn't realised that the problem that I was having. I didn't realise that the fit in the sleeve here was very, very, very close running fit. When you're at that point it's loose, and when you get to that point there's absolutely no movement at either end. And when I look very carefully, just turn the light on, you can see scraping marks inside, some of which are the ones I've put in and some from the original. So the original was scraped in. Sounds unbelievable really, but that's how they did it. They scraped it in, presumably to fit this. Anyway, I was faced with a problem. I scraped, as I mentioned, this surface so that it was at the right angle and centered correctly, and then I scraped a little bit on the inside here, thinking that that's what was causing it to bind up, and it still was binding up, and I couldn't think what to do. And in the end, a flash of inspiration was to, I've got a diamond hone stone, which is absolutely perfect for this job. I'll just get it so you can see what it looks like. This is the stone I used. It's 600 grit on one side and 1200 on the other, but 600 is adequate for this, and you can see it's just a nice width. So I was able to put that, mount that in the chuck there with this protruding, and then just take the merest smidgen off here. It probably took no more than probably 2 or 3 microns. It wasn't much more than that, and once I'd got that eased off, when I put this in, it drops down with a satisfying click, and it doesn't have any trace of sticking, which is what it was doing before. And if I run this at any kind of, with any kind of speed in my fingers, it produces little lines around here, and that's caused by it being such a tight fit inside here. And ideally I'd like to scrape a bit further in, but I haven't got anything long enough to be able to scrape that deep. So I probably will just take a touch more off so that that is as free running as possible. Oh, and that might interest you too. That's been beaten on by somebody with a hammer. Oh, I wish people wouldn't do that. By all means use a hammer, but use a dead blow hammer. So that's now running nice and free. So I'm happy with that. Now what else was it? Oh, when I took these plates off at the back, these screws had never been out before because they were very, very stiff inside, and clearly this is the original plate. If you look there, you can see the number 19 for the batch stamping for that, and this is the plate that screws onto that. It goes on there, and somewhere there was oh, it's got right and left stamped on there, which is quite helpful. I think I saw a 19 on this one as well, somewhere. The main reason that there had been a problem with this was that it wasn't getting oil in properly. You see the screw in the front there. That screw leads through into here, and at the back there's a screw that goes effectively through that hole. Now you can see the number 19 stamped on there as well. There's this plate the oil hole here goes through into there, and that goes through into the underside in there, but our oil wasn't getting through, and I have to just think whether there's a better way of accessing the oil, because once you've got this on and you've got there's a plate that goes on top of here, there's no way of getting oil into it, and this plate goes on there, so that'll be hidden. Very reluctant to drill any extra holes, but I think one's going to be necessary. Might be even better to put one in the top of this block. Yep, I think that's what might be the best way to do it. And actually put in an oiling point, a proper one. I'll think about that, but I can't have that problem happening again with it not getting any oil. Oh, this is the way I'm going to deal with the chuck, I've decided. Of course, this takes a much larger collet, and I haven't got a set of 4 NS collets, which is what it needs. I've got the dimensions of the collet size, so I can easily make something. This is what I did for the Sloan and Chase lathe. I made up effectively a dummy collet with a chunk sticking out, and then turned an ER20 collet chuck on the end, and I think I'll do the same with this. So effectively I've got a collet chuck sticking out of the here, and that can be secured with the closing tube on the end, which goes through here. So that's where I'm at now. This is all nice and tidy. Oh, I did manage to get hold of pulleys, so I'm going to, these are commercially available pulleys in pretty well the right size for this particular job. So I think I'll probably use that. They weren't expensive. So yeah, good progress so far. There's a handle that was all bent and I couldn't straighten, so that's the replacement I've made. So the next bit, I guess, probably to make is the part that sits on top of here. So I'll have to draw that up on the computer and make that up. One thing on the subject of oil for the spindle, I've just experimented a little bit with various viscosities of oil which I happen to have. EN 32, EN 46 are too thick, and the best one seems to be number 10, premium spindle oil. It says viscosity 22, and it's a good deal thinner than the 32 which you use on Myfords and things like that. So anybody who has one of these, I'd suggest that that's a more suitable oil. If you use the thicker oil, the fit of this is such a tight fit, it doesn't seat itself properly, and this is still free running even though it's sat right on the cone there. I've completed stage 1 of making the top hat part. I've just made a mark on there, and between there and there I'll probably machine off in a straight bevel first and then cut the curve. This was a bit of a pain to do. I discovered that these screws are not geometrically patterned around anything, so when I drew it up on the computer and tried to reproduce it on the top, it just wouldn't do it. So I in the end had to mark the position of these by marking it with chalk on the bottom one that had already been drilled, and then transferring that the chalk marks onto the underside of here, scribing a circle, making the centre of it, and even then it's quite difficult to get them absolutely spot on. But the holes varied quite a bit in size, in position, rather annoying and rather surprising, as even the pegs that hold it in, the pins that hold it in place and secure and lock it in place, weren't on a direct line across. They were slightly offset, and I would have thought if they were doing these in a batch that they would have at least had a jig made up for all the hole positions and be able to pop it on top and then just drill through. But I guess they didn't want to do something quite as simple as that. The other thing is, it's not actually completely round. The shape of this doesn't follow exactly the shape of the top that I've turned, but never mind. It's going to look alright when it's finished, and I've got one side to cut off still on this side, where the back of it goes up and down. So next to tackle that. I thought you might like to see this. This is how I'm doing the cone, which has got a curve on it. I've got a checked radius here to check up against this to see when I'm getting somewhere near, and the whole lot in cast iron is turned by hand. I've got a Sandvik insert just as a hand lathe tool, and I'm running at about 500-600 RPM, and it cuts quite nicely. As you can hear, there's a bit of chatter, just a bit up here. This end is pretty good, probably because it's running a little bit fast. But by altering the angle and by increasing the pressure, it's possible to remove most of the chatter, and it really isn't too much of a problem. And then, as I say, I have to just check with my little guide to see, and I'm getting there. The one thing obviously you need is a more curved radius on here, to make sure that you have not too large a cutting surface. Anyway, that's how I've done that. Well, it seems unlikely that you can turn by hand, but this has worked fine. And that's again that's the hand scraper that I've been using. And that's now pretty near the right profile, and it needs a good polish, and that's about it. Little bits I can clean up, but it's actually turned out quite well. I've gradually got on top of the speed, and I reduced the speed a little bit, and that worked better. So it just needs a good polish, and I've got to insert the Acme nut in the end there, and what I'll do is I'll bore out and narrow the nut down a little bit so it fits in there. I've finished the curve and polished it. I've recessed the screw holes, and I've just machined out the inner bore here. This is to take the Acme screw thread, and what I've done is I've bought a nut which I can turn down to fit inside there, so I haven't got to, it's a shortcut really, I haven't got to cut a thread inside there. So I'll put that in and glue it with Loctite. Seems I've now completed the Acme screw that lifts and lowers this up and down. I'll just undo these screws and you can see what's underneath. And this is what I put underneath. It's a bronze disc, 4mm thick, that fits almost flush but just slightly up underneath there, and that very neatly hides all these holes on the top. I put an oiler in there, and I'm going to retain the screw oiler at the front just simply because it's at an odd angle, it doesn't sit flush, and the screw will work fine. I filled that hole there, which you can hardly see, and a hole there, and a hole there, and a hole there. So with this on here, there are no more visible holes. So I'll just pop this back in, and you can see that the screw doesn't move around very much at all, which is how it should be. Oh, I've just put a touch of oil on there. I think we're ready to start thinking of assembling this completely. It's always a good idea when you're fitting these parts and taking them apart to label them, so that I've put a little R on there, so that's to the rear, so that they're assembled the same way around, because even with trying to get everything as accurate as you can, it is possible to have slight differences between centres of screws. This solves that problem. Now you can see there's very little movement in that. So when we fit it into the inside here, and fit this on the top, it should screw down without a problem. I now screwed the back plate here onto this, and there's a little bit of movement, but very, very little, and it goes up nice and smoothly up and down. To just make sure this back plate is tapped on firmly. And just tighten these screws one more time. And this little fastener on the top locks it solid. And tighten that up. That's better. So there's no play there, and there's actually very little play between the up and down. And so it locks not only with this screw, but it also locks with this plate here and the two bronze pins that go through here. And these studs just project out enough to be able to push them up against the face here to lock it. So it's going to be a very robust, secure way of doing milling in the lathe, that's for sure. I'm not too happy with these screws, so I've got some new ones coming. And I can still get at this oiler, which is what I was concerned about. This one here will be covered up by however I choose to make the motorised attachment for running the thing. So the original arrangement had the pulley out at the side and two brass or bronze bushes running in the steel block. I'm not quite sure whether I'm going to do that and use the gearing that was used, or whether I opt for something simpler like a pulley and then put a bracket out here and a motor facing this way with a small pulley on it. I think that might be easier, so I'll do that later. I've trimmed off the ends in here of the insert plugs, and I've actually got some rather neater screws, so I've shortened them a bit. I don't want to shorten them right up, and it takes very little force to make the gibs lock, so just that much. So the screws they really don't need to be tightened, don't even need to be there. It's very robust apart from when it needs to be locked. Right, now when I took this apart I had a struggle to get it apart, and the one thing that was a problem was getting the slider off the top. And what I discovered was that this block, the screw, goes in there and it's got no fixing on it at all. It's just merely a friction fit. So it's pushed into that hole, and to get it apart you go through this hole here and tap it from the top until it comes out. So it actually wasn't difficult at all once I got the hang of it and knew what I was doing. I'm left now, so I've got the motor drive assembly to think out and to make up. I think I'll probably end up, this is getting a long video, I'll probably end up with a second video with the motor drive assembly. So I'm happy enough that all of this now works nicely. So that's there, you can lock it, and you can lock this plate against here. I mean, the whole thing works fine now. This is nice and rigid. Yeah, the only thing is how to drive it, and I've come up with a 24 volt motor, which will probably, it's 500 watt motor for 24 volts. I don't like using mains power on the top of a lathe just in case something comes off. It's probably safer to use a lower voltage, and that's what I'm going to do. And the other thing I've got to do is to make up the Arbor, which will be a version of this to fit inside the spindle. You can see, I don't think whether I showed this particularly, this is the little bit that I machined off and then added back to stop the slop in the top, so when this pulls up tight on here, when it's screwed up tight, it doesn't slop around, which is the reason that this bit was all added on in the first place. Well, I'm very happy. It's turned out to be a bit of a job to do, but I've enjoyed doing it, and it's the important bits weren't heavily worn, and I'm delighted to have got it. What I would like is the other parts of the mechanism. There's an arrangement which allows you to cut spirals, which uses something attached to the nose of the spindle to regulate the speed at which the carriage moves up and down the lathe, allowing a very coarse screw to be cut. I think it's very unlikely they're going to appear ever on eBay. It's almost never that anything like this even comes up, so I'll have to think very carefully about whether I want to the original arrangement or whether I do it with an electronic version, because I could do it with electronics. Now think about that.